if you follow AI agents. This is worth your attention for one simple reason. A lot of agent failures are not really model failures. They are memory and retrieval failures. OpenViking is an open-source project from VOLC engine that says the usual flat or AG pattern is the wrong shape for long-running agent work. Instead of treating context like a bucket of chunks, it treats context more like a file system. That means memory, user preferences, skills, project files, and instructions all sit inside a hierarchy that an agent can browse. The immediate promise is practical. Better retrieval, less prompt bloat, more visibility into why an agent grabbed the wrong thing. The reason to care now is not that this replaces our AG overnight. It is that it offers a clear operating model for agents that need persistent memory and repeatable behavior across sessions. At the center of OpenViking is a virtual file system exposed through the Viking protocol. Context is mapped into top-level directories like resources, user, and agent. Inside those, the system can store documents, preferences, skills. I'm going to teach you how to finally think and speak English. Instructions and task memory. That sounds simple, but the design choice is important. It turns context from an undifferentiated retrieval store into something with explicit structure. An agent can browse with file system style actions like ls and find, instead of relying only on semantic similarity over a flat index. The point is not to remove embedding search. The point is to constrain it with a hierarchy. In practice, that gives developers a more deterministic way to organize memory and a more legible way to reason about what the agent can see. For product teams, that shift may matter more than the phrase context database suggests at first glance. The core mechanism here is called directory recursive retrieval. OpenViking first uses vector retrieval to find a strong directory candidate. Then it retrieves again inside that directory, and can keep drilling into subdecretor CFEs if needed. So this is still semantic retrieval, but wrapped inside a file system path. That matters because it tries to preserve the things at once local relevance and global context. A matching paragraph is more useful if the system also understands the folder it came from, whether that is a project area, a user profile, or an agent skill set. OpenViking also adds tiered context loading. L0 is a one-line abstract. Load is an overview. L2 is the full content. The intended payoff is lower token use. Because the agent can inspect summaries first and only pull the original material when the task really needs it. That is a concrete systems improvement, not a vague memory claim. One of the sharper parts of this design is observability. OpenViking stores the browsing path and file positioning trajectory used during retrieval. The project describes this as a visualized retrieval trajectory. That may sound secondary, but for agent systems it is a big deal. Teams often debug the model when the real issue is context routing. If the wrong memory or skill is fetched, the answer degrades even when the model itself is capable. A visible retrieval path gives developers something concrete to inspect. OpenViking also pushes beyond simple check history with automatic session management and a memory self-iteration loop. At the end of a session, developers can rigor extraction of user preferences and agents' operating lessons, including things like tool usage, patterns, and execution tips. So the product idea here is broader than search. It is trying to become a persistent context substrate for agents. The project reports OpenClaw plugin results on the low-code and long-range dialog dataset. in the published setup. OpenClaw with memory core reaches 35.65% task completion with about 24.6 million input tokens. OpenClaw plus the OpenViking plugin is reported at 52.08% with about 4.26 million tokens, and 51.3% with about 2.1 million tokens depending on memory core configuration. If those numbers hold up, the pattern is interesting. Better completion with far lower token use is exactly what this architecture is aiming for. But this is where restraint matters. These are project-reported results, not independent validation. And the article does not establish how broadly this transfers beyond the stated setup. So the real takeaway is narrower. OpenViking presents a coherent design for structured agent memory. The benchmark signal is promising. The proof that it generalizes is still pending.